Hi dear, today we'll continue with the chemicals manufactured from the or obtained from the NaCl, that is common salt. Okay, so far we have seen the sodium hydroxide, bleaching powder and baking soda, right? So today we are going to see the washing soda. Okay, the common name is washing soda and the chemical name is sodium carbonate decahydrate. Okay, sodium carbonate decahydrate. Okay, so how it is formed is, we are already seen the baking soda preparation, right? When the baking soda is heated, that is sodium hydrogen carbonate is heated, it will give sodium carbonate, right? That sodium carbonate we are going to use here. Okay, how we use in the manufacture of bleaching powder, whatever the chlorine obtained from the manufacture of sodium hydroxide, you are using that chloride and it passing to the calcium hydroxide, right? We'll get bleaching powder likewise. So in the using this baking soda, we are going to prepare this washing soda. Okay, baking soda, when heated you will get sodium carbonate. That sodium carbonate we are going to use here. Okay, it is obtained by recrystallization of sodium carbonate. Okay, when it is heated you will get sodium carbonate. Again, when it is recrystallization, and during the recrystallization process, when water is added. Okay, when water is added, sodium carbonate plus 10H2O gives sodium carbonate dot 10H2O. This is your washing soda. Okay, Na2CO3 dot 10H2O, that is, it is in the crystal form. Okay, because it contains water of crystallization. Okay, 10H2O. So it is a, you know that it is basic in nature, it is a basic salt. Okay, so what is the purpose? Washing soda, the name itself, it gives us, it is used for washing purpose. Okay, washing purpose in laundry and for softening of the hot water. Okay, if you mix the washing washing powder in the hot water, it becomes soft. Okay, you can get the lather. Okay, as a laboratory reagent. Okay, it is used as a chemical in the most of the laboratories and used in the glass, soap and paper industry in the and also it is used in the manufacture of sodium compounds such as borax. Borax is used as insecticides. Okay, to kill ants and all. Okay, so these are the uses of washing soda. So far we have seen what are the chemical products formed from the common salt. Sodium hydroxide, NaOH, and then bleaching powder, calcium hypochlorite, then baking soda, NaHCO3, sodium hydrogen carbonate, then washing soda, Na2CO3 10H2O. Okay, so these are the main chemicals we are using in a day-to-day life. So these are produced from using the common salt, NaCl. Okay, next, so I have used the word here, the water of crystallization. This sodium carbonate contains 10 molecules of water, right? So this is called water of crystallization. When you add water to this Na2CO3, it will not exist in the water form itself. This water exists in the form of crystalline structure. Okay, that is water of crystallization. So what is meant by that? Water of crystallization, it is the fixed number of water molecule present in one formula unit of a salt. For one formula unit of a salt, how many molecules of water is fixed? That is called water of crystallization. Okay, are these crystals are really dry? If they are asking question like this, actually in the book it is given, the topic has been given as, are the crystals of salts really dry? Yes, it is dry only. It will not exist in the form of water, it will be exist in the form of crystalline structure. Okay, so for example, one of the example is sodium carbonate, Na2CO3 10H2O, and then one more is copper sulfate crystal, CuSO4 5H2O, and another one is exists in the form of water crystallization is water of crystallization is gypsum, calcium sulfate dot 2H2O. Okay, calcium sulfate, CaSO4, you have to read this as CaSO4 dot 2H2O. The chemical name is calcium this is chemical formula, and this calcium sulfate dihydrate. Okay. So using this gypsum, we are having one more chemical product, that is your plaster of Paris. Okay, plaster of Paris have many uses in day-to-day life. So that is also manufactured from the gypsum. Okay, so we are going to see the use of that gypsum only. Okay, so it is used in the manufacture of plaster of Paris. The common name is plaster of Paris and chemical name is calcium sulfate hemihydrate. Okay, CaSO4 half H2O. Okay, so here how many water molecules are bounded means this half molecule means it is attached to this one formula unit contains half, means that means one water molecule is shared by two formula units. That's why one contains half molecule and another CaSO4 contains half molecules. Okay, so one molecule of water is shared by two formula units. Okay, so how it is obtained? It is obtained by heating gypsum at 373 Kelvin. So if you heat this gypsum at 373 Kelvin, it automatically lose water. Okay, you know that gypsum contains two molecules of water, right? Dihydrate. It loses its water molecule and it becomes calcium sulfate hemihydrate. CaSO4.2H2O upon heating at 373 Kelvin, it gives CaSO4.H2O plus 3/2 water molecules. That means what? 1/2, 1.5 water molecules. Okay, because it contains two water molecules, half molecule is retained in the CaSO4 and another 1.5 is here. Okay, it comes out as a vapor. Okay, next, this plaster of Paris is a white powder. Okay, it all the water molecules are lost, so it becomes a white powder. And if you mix water with that, it again changes to gypsum. Okay, once again giving a hard solid mass, because it again this gypsum contains two water molecules. That means it is not in the slurry form. Okay, it is in the crystalline form. That's why it gives hard solid mass. Okay, the white powder is again converted into gypsum by adding water. Okay, mixing it with water. That is calcium sulfate hemihydrate is reacted with 1.5 molecules. 1.5 means what? So again this 2 ones are 2 plus 1 3. 3/2 water molecule. Okay, 3/2 water molecule, it will give CaSO4.2H2O. That is calcium sulfate dihydrate. You will get the gypsum again. Okay, it is reversible process. Okay, when you again heat this we can even put this. Okay, when you heat this is on heating. Okay, cannot put like this. Okay, upon heating this gypsum, again you will get this plaster of Paris. When water is added to the plaster of Paris, you will get the gypsum again. Okay, next, so there are many uses of plaster of Paris here. It's used for making the statues. Okay, casting of statues. In the doctors used as a substance to join the bones, broken bones, or to keep the displaced bones in the right position. Okay, in making a wall border, you would have seen white color borders in the walls, right? That is all made up of a plaster of Paris. Making a wall border as a fireproofing materials. Okay, for making a smooth surface of the wall. If you touch some of the walls, it is very smooth, because after plastering they will be again plastered with the plaster of Paris. Okay, plaster the wall with the plaster of Paris, then it gives a smooth surface. Okay, and for making toys and decoration material. Okay, that's all with this layer. We have to see only the remaining activities. Okay, thank you.